Hello guys, welcome back to a new video, and in this video I'm going to be covering how to turn large numbers into scientific notations. So, scientific notation is a way to write very large or very small numbers using powers of 10. We use it because numbers like millions, billions, or tiny decimals are hard to read and write in standard form. So, to write the number in scientific form, the first step we're going to take is we're going to move the decimal to its right after the first non-zero digit. As you can see here, if you forget this, you can just read this one again. So, after we did that, we're going to count how many places the decimal moved. So, and one more thing, if the original number is large, the exponent is going to be positive, and if the original number is small, the exponent is going to be negative. So for example, these are all large numbers, and in the next video I will probably do one with small numbers so you can see how that works. So we have 4 examples on your screen right here. We're going to go through all of them 4 together to get this down. So the first example we have 8,400. So the first step we're going to take again is we're going to move the decimal to its right of the first non-zero digit. So the first non-zero digit is an 8. So we're going to move the decimal to the 8. So to do this, we're going to start over here and we're going to count how many times the decimal is going to move to the left to our decimal right here. So we're going to do it like this. 1, 2, and 3. So our decimal is moving 3 times. So our decimal is right here. So now what we can do is we can rewrite this number like this, 8.4. And then again, we're going to count how many times the decimal moved to this spot right here. And that's 1, 2, and 3 times. So we're going to do times 10 to the power of 4. And this will be, oh, my bad guys, not 4, because we moved 3 times, not 4 times, little mistake. So 8.4 times 10 to the power of 3. So this will be our our answer for the first example. So, and don't get confused by these two zeros right here. You don't have to put these in your answer because again, any zero to the right of the decimal doesn't have any value. So for the second example, we have 32 million. So again, the first thing we're going to do is we're going to move the decimal to the right of the first non-zero digit. The first non-zero digit is a 3. So we have to get this decimal to between the 3 and the 2. So let's do this starting from here. So we're going to move 1, 2, 3, 4, 5, 6, 7 times. So now, again, we can rewrite this to right here like 3.2. 3.2. Now, again, if you forgot, we can count it one more time how many times the decimal moved to the left to get in between the 3 and the 2, and that was 7 times. So like this, 1, 2, 3, 4, 5, 6, 7. So we're going to do times 10 to the power of 7. And this will be our final answer of the second example. So now we're going to go to a very large number. So for this number, we're going to do the exact same thing, starting with moving the decimal to the right of the first non-zero digit. So the first non-zero digit is going to be this 9 over here. So we have to get the decimal in between the and the 0. So let's do this starting from the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So as you guys saw, we moved the decimal 11 times. Now we're gonna rewrite this with the decimal in the correct spot right here. So we're gonna do 9 point, because we moved our decimal to there, and then 0, 5. So 9.05. And then we have to do 10 times 10 to the power of 11. Again, we're doing to the power of 11 because that's the amount of times the decimal has moved in between each digit to get to our correct decimal spot. And this will be our final answer to our third example. Now, for our last example, we have a very large number. So, this may seem a bit more harder, but it is actually the exact same thing. So, the first step we're going to take, like the other three examples, we're put the decimal to the right of the first non-zero digit. In this case, it's this here. So we have to put our decimal in between this 6 and 7. So we're going to from here counting to the left. 1, 2, 3, 4, 5, 6 times 7, 8, 9, 10, 11, 12, 13, 14, and 15. So now with the decimal in the correct spot, again, we can rewrite this with the decimal between the 6 and the 7, like this. So now we have our 6.7, and now we're going to do times 10 to the power of, and then again we're going to count how many times we moved our decimal. So I remembered it was 15, but of course we're going to count again for you guys. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So this is going to be our final answer of our last example. So remember, move the decimal, count the spaces, and use a positive exponent for big numbers. And that's basically scientific notation. So this was the end of the video. I hope you guys enjoyed the video. If you did enjoy the video, make sure to leave a thumbs up, subscribe to the channel, leave a question in the comments, and as always, this was Mr. Mathz, and I will see you guys in the next one. Bye.